Well, hello there. This is Craig Hain, and this is going to be an addendum to Chapter 4 video of the book How and Why Homeschool Math Can Be Vastly Superior to Public School Math. I'm Craig Hain. This is part of Triad Math Inc.'s wonderful program, and this is Chapter 4 that you should have already watched the video on, and this is an addendum because now I want to discuss the specific topics that your student will be learning in the first two tiers if they are not college bound. Okay, here are the things that the student's going to learn. All of our students start out in tier 1 on how to use a scientific calculator. Now just look at these topics. Each one of these is a video, like squares is a 3-minute video, square roots is a 5-minute video. They come with exercises and quizzes, and a student must do these sequentially, and it's all kept track of in our learning management system, so you as the coach will have access to the administrative features of that, and you can see exactly how your student is progressing. Now I will tell you, this scientific calculator training is very exciting for most students. It's very kinesthetic, it's easy to do, they love it, and they're so proud of themselves when they can do it because now they actually can do something. They're doing things with math that is very kinesthetic. They can see it's going to be practical and useful, and they love it. And you as the coach want to brag about it and compliment them on it and so on. And it's amazing how quickly they'll go through this. Most students, if they work on it diligently a little bit every day, will go through this in 2 or 3 weeks. Now pre-algebra is simply nothing more than the review of all the rules of arithmetic that they've already learned as elementary students. But now they apply the calculator to doing it, to using all those rules that you may have taught them manually if you haven't already taught them how to use the calculator. So this also now just is a combination of a review. For some students, some of it's new. For example, using the calculator for fractions is wonderful. So much easier than doing it manually. Nobody would do fractions manually anymore when they've got a calculator. And you can't even do things like square roots efficiently and exponents and so on. Now, after they get through the calculator training, then we give them algebra. Now, you'll notice there's only 10 lessons of algebra. Now, you compare that to the huge textbooks that cost hundreds of dollars that the schools use. And they're loaded with material that is theoretical, of no real interest to practical math. They're also loaded with a lot of obsolete algebraic manual techniques that were developed by our ancestors back in the 1700s. And it's been like this for over 100 years. These algebra books today look fancier. They're bigger, they're thicker, they're more expensive. They got pretty pictures in them. But the math could be 100 years ago because it's all manual stuff. And anyway, it's a lot of stuff you don't need. So this is all you really need for practical math. It's pretty amazing. And students go through it pretty quickly. And then we do geometry. Now, they love this because this is straight lines and triangles and angles and things of that nature, circles. And then, of course, solid figures, blocks and cylinders and cones and so on. And each one of these, notice, is a video, like the Pythagorean theorem is a 12-minute video and so on. And by the way, you might take a look at this if you're a math teacher and see out of these 19 lessons here, which one do you think is the most important lesson that is used the most frequently in practical math? And I've been doing practical math in all sorts of subjects, technical subjects, for decades now. And let me tell you what you use probably more than any other single thing. G6, similar triangles. Similar triangles are used so often when you're analyzing a practical math problem, it's unbelievable. And of course, that's what we teach them how to use. And of course, to do that, you have to have algebra. In fact, most of these things that you do with geometry involve algebra. Algebra and geometry go together to solve problems. You can't do... Now, the way geometry is often taught in schools today is proving a lot of theorems. Well, I prove a few theorems here informally, but that's not what we focus on. We focus on using geometry in practical math, and that applies to just literally hundreds of different technologies. And then finally, we do trigonometry. Now, this first pass through trigonometry is just how to do triangles and what to do with triangles. And it's really quite easy to do. It's an extension of geometry and algebra, and there's things you can do with trigonometry that you can't do with algebra and geometry because it involves angles. And then, of course, what makes this so easy now is going to be the scientific calculator. In the old days, this was kind of hard to do because you had to use trig tables and look things up, and it was pretty difficult. And the most interesting thing in trig, the most valuable thing, is law of sines and law of cosines. In fact, I call the law of cosines the generalized Pythagorean theorem. Now, one of the problems I gave you in one of the, I think, other chapters, I think maybe chapter 2 or 3, was a problem. I have a one-question test that I give students to see if they know practical math. And what I do is I give them an arbitrary triangle, and we make up the lengths of the sides arbitrarily, and then I say calculate the area. And it's easy to do if you know how to use the generalized Pythagorean theorem and some other things. And they learn to do that. And then it gives them something that they can do that very few people can do, and it's a wonderful thing. So this is what we do now in our practical math. Now, there's one more thing that we do, and I told you that if your student is going into the workforce, there's one more thing that we give them. If you go to our workforce math site, you will find that this is the math that the workforce needs. And this is something that when I sold my company, Hain Training, to Advanced Technology Services, the math that they need for all of these technical, all that technical training is given here in this. Now, this is a pretty expensive program. If you buy it, if you're like a company buying it for your workers and so on, it's fairly expensive. But what it involves is basically what's in Tier 1 and Tier 2. In other words, you're really getting in Tier 1 and Tier 2 the bulk of what's in this program. Now, it turns out that there are some topics in this program that you get. Here's the syllabus for the program. This is for the advanced program. And if you go down and look at it, it costs $397, by the way. So now you're getting this as part of your family plan. I mean, you're not going to be paying this kind of money. You're getting it not for free, but pretty close to it. Well, here it is, using the calculator, the basic algebra, which you've already seen, the intermediate algebra. Well, that's basic pre-algebra. The algebra, I call it intermediate. And then then geometry again. And then what we give them in the intermediate, we give them these special topics: units, conversions, DMS versus decimal degrees. You could do this with your calculator, but I haven't taught you that yet. Exponents, density and weight, the difference between floating point, scientific, and engineering formats. You need to understand that if you're going into a technical field. So you're going to get these special topics now as part of the quantitative reasoning that we're adding, and it's these special topics that are available. And then when you get into the advanced, that's just more of the things you've already learned in Tiers 1 and 2, and then again, more topics: prefixes, the technician's triangle, polar rectangular coordinate. Now, I will tell you something. Prefixes and the technician's triangle is how I made a fortune. Because when I started teaching electronics in 1980 to technicians in the military and in industry, they call them skilled tradesmen, is what they call them. One of the things I did is I taught them how to do the calculations they needed to do in their troubleshooting that involved prefixes, things like milliamps and nano and kilo and mega and all that. And then I taught them to use something I call the technician's triangle. I've never seen this in any book anywhere. And that's what I built basically the company on. And that company became a multi-million-dollar company. We trained thousands and thousands of technicians. And these special topics are almost worth their weight in gold. Just these two things alone. And you're going to get that in the quantitative reasoning and that'll soon be available. It isn't today, but it's going to be very shortly. And so if you have a student that is going into, not going to go to college, but is going into the workforce, military or apprenticeship programs or whatever, you're going to get these special topics, and that's going to be a phenomenal thing. And so however you train your student, that's what I want you to keep in mind. So this is Dr. Dale. I wanted to give you the supplementary material to go with Chapter 4, and then I will see you on some other videos, and I wish you the very best in giving your student an optimal math education. I think that you'll just be so proud of what your student's going to do when they learn this. The student's going to have self-esteem. They're going to love it. They're going to know math, by the way, now that very, very few people know. There are not very many people even in the industry today that know this stuff unless they've taken my training. So this is Dr. Dale. I'll see you on another video.